So last summer we spent time in 4 different rivers in Minnesota trying to understand the effects of suspended sediment. So one of the things that we discovered is that there's a correlation. High sediment loads, where there's lots of material in the river, means that there are low populations of mussels. So what's right here next to me is essentially a fake stream where we can control everything from what the vegetation looks like around the stream to how much water we move through the stream system. So it gives us an opportunity to do river science in a pretty different way than most folks are able.
In this controlled environment, we're able to know more stuff about what's actually going on in the river system. So we can control the water flux as well as the sediment input, and we can also change the bed if we need to.
So what we're starting to see is that during floods, the mussels tend to kind of hunker down. So sometimes they'll bury themselves in the sediment, sometimes they'll move to a deep spot of the river and stay put. And then once the flood is over, we tend to sort of see them adjusting themselves.
Today we're doing post-flood measurements of the mussels. So we flooded 2 days ago, and now we are looking at their location along the stream, as well as how much they're buried into the stream.
We've been, I think, all surprised by how much they actually can move in a given day. I mean, some of these mussels move meters per day. These native mussels in Minnesota, some of them are endangered species. They're one of the reasons that rivers actually stay clean. What we ultimately want to know is how stressed mussels are. So if the mussels are doing well, that means that the water quality is probably pretty good. Ultimately, our hope is to understand, right, what are the conditions under which mussels thrive.